think ideally what we would like to accomplish in the next hour is to really have an open dialogue. So feel free, everyone, to just sort of jump in and discuss. So Jake and I will start by addressing a few questions directly to the panel, and then later on we would like to open the floor to anyone that has questions in the audience. So I think in order to get started, it would benefit everyone to sort of hear a little bit from you individually. We would just sort of like to hear a little bit about your background, where you're from, your education, maybe tell us who you worked for while you're at Brookhaven, and where you are currently. So if we'll just start at the end, we can work our way down, and that way we have a good idea of maybe who you are, where you're from, so that we can ask some specific questions.
So I'm Mark Doherty. I was here for about 3 years as a postdoc. Did my undergraduate at RPI in upstate New York. Went to University of North Carolina at Chapel Hill for a PhD in inorganic chemistry, focusing on organometallic chemistry and catalysis. Came here to work with Etsuko Fujita in the chemistry department, doing photochemistry and catalysis related to CO2 reduction, some hydrogen reduction work. And I've been at GE Global Research in upstate New York, just outside of Albany, 25 minutes northeast. Doing chemistry as part of we have an EFRC program, one of the 46 funded by BES, and it's the only one that's led by a corporate research lab. So its goal is to come up with some novel energy storage technologies, and I'm still doing a lot of the chemistry work that I did here, up there. And I've been there for, like I said, about 3 years.
I'm Tianna Hicklin. I was at BNL probably 2.5 years ago, and I spent 4 months living and working at the lab as a science communication intern in the Office of Communication and Public Affairs over in Building 400. And I took that internship right after I completed my PhD in neuroscience at the University of Colorado, following an internship I had in the public relations office there as well. And let's see, I'm currently the assistant editor in the custom publishing office at Science AAAS, the American Association for the Advancement of Science. Hopefully you're familiar with that. And yeah, so I'm came to Brookhaven not as a scientist, but to transition my career into publishing and science communication. So it's kind of an alternative career choice that I'm happy to share with you.
Hello, my name is Carl Andre, and my education is from North Carolina State University and Michigan State University, and with a background in biochemistry and plant biology. I came to Brookhaven in 2007 as a postdoc and worked for John Shanklin at the time in the biology department, now I think in biosciences. I left just about a year ago, and now I'm at BASF Plant Science, and we're agricultural biotechnology part of the larger company BASF.
Hello, I'm Yolanda Small. I'm assistant professor of chemistry at City University of New York in Jamaica, Queens at York College. I came to Brookhaven as a postdoc in 2007, and I started my postdoc career with Jim Davenport in the Computational Science Center doing biofuels calculations on the blue gene, which was new at the time. And then I moved to become a postdoc in the CFN, but with Jim Muckerman in chemistry, working on hydrogenase enzymes calculations. I currently still do, I'm still a user of the CFN now with my students from York College, and so we come back here pretty much every summer. I've been at York since 2010, and so we've been back here every summer as users of the CFN doing calculations on more silver clusters, looking at how we can build new materials that are more photocatalytic materials.
Hello, my name is Maye. I'm originally from SUNY Binghamton, where I received BS and PhD in materials chemistry. I was a Goldhaber Fellow here with Oleg Gang in the CFN from 2005 to 2008. Now I'm assistant professor of chemistry and biomaterials at Syracuse University, And our group also uses the CFN every few months or so.
All right, thank you. So we actually polled the postdoc community to see what questions they would like us to ask and you to answer, hopefully. So the first two, I mean, since we have an industry and academic and also a sort of non-traditional career, these questions are a bit specific. So first, I'd just like to ask if Carl and Mark could answer this one. You've said what you do in industry briefly, but I think one of the curious questions was, how do you transition from fundamental research into working in a company where you actually have to make that transition into a marketable product or something, sort of thinking further in a bigger sense, I guess?
I'll go first. So it's sort of not maybe the answer you're looking for, but so the EFRC that I'm part of is fundamental science. So in that sense, that program, there's no product that we're actually trying to make. I am also involved in other programs where there is a product down the line, maybe 5, 10 years or something like that, but I'm still in the lab doing the same kinds of experiments I was doing here. There's maybe some more specific goals, not necessarily looking towards publishing, although the EFRC, that is definitely one of our goals. Some of the other programs, if it's something we want to publish, we'll publish it or patent or do whatever. So it's a lot of the same kind of experiments and meetings, everything that we were doing here or in your PhD training.
For me, the transition started during my postdoc because I was working on a project that was funded by industry, and having a project like that brings the perspective. You're doing basic science, but you're also communicating with someone in industry who, pushes you in a certain direction, which is towards helping them develop a product. And when I joined BASF, I'm now definitely working fully towards making a product, and you have to learn to not be so personally tied to a specific project and more personally tied to making a profit. And that's a big transition, but it still requires science and solving problems. So what you do from day to day functionally is the same. And the biggest transition for me is broadening what I work on, because anything could end up being a product.
Great, thank you. This again is for you, Carl and Mark. How do you think that your scientific knowledge translates into your product development or market needs? I guess maybe this is geared a little more towards Carl, who's working with specific products.
Well, where I work, a lot of product concepts come from the scientists. So there's a lot of different ways that we can propose ideas, and if they are acted on, that's the decision of the business people. So use your scientific knowledge to make the best argument for what you think a product could be. And if you're not like me, and if you have any business knowledge, you can kind of bring that into it. So that's something you have to learn. But we learn how to formulate arguments. I think as postdocs, if you have some hand in making grant proposals and writing papers, that's very valuable experience when it comes to proposing product ideas. And then products aren't easy to make, and there's always challenges, and being a scientist, you're really a problem solver, and that's important no matter where you are. So I think being trained as a scientist works very well, and that's how I use it.
I would agree with that completely. The proposal part of that, especially, I'm not sure how it works with BASF, but a lot of the times, you get together with either someone who does know the business side of things that you maybe don't, or someone else who knows more, has been there for 20, 30 years with more experience. Put together a really short kind of white paper proposal, see what you get, a little bit of money, do a couple experiments to show, hey, this is worth trying to give me some more money, and then go pitch that to someone else and see if they're willing to buy into that, and then take it from there and solve whatever problems they need. Hopefully, the idea you've got is something that they need right away. If not, you can keep pushing at it, because usually it's something that they need. It's just not right away. So it's a question of their priorities as well.
All right. So for Matt and Yolanda, I think usually a lot of postdocs out there, we kind of know what it's like to be in academia, as we've all had to go through getting a PhD. But we were wondering if you could tell us maybe something surprising or unexpected that you have experienced since becoming a professor.
I guess I'll go first. I guess the biggest shock right away is here, you're 110%, 120% into your research. And there, right away, it drops to maybe 60, 65% of your time. Even though you want to focus on it, it just drops quite a bit. And it's a little bit of a shock to have to worry about some other things sometimes. So I think the biggest shock for me was really, I thought that I would be able to still squeeze 90% of my time into research and teach 10% of the time or advise 10% of the time, but it really is quite a good hit. The other small thing is when you have a relatively big group or a lot of undergrads, you become almost a human resource person as well. So you have to worry about the research, your teaching, and then some interlab dynamics between students, or some student might come into your office and have some pretty big problems or pretty small problems that they think are big, and that might kill an afternoon. So I think the biggest change for me was really I wasn't completely sure exactly how much time it would take in these other non-research aspects. I think that was the biggest surprise for me.
I echo all those sentiments, and I happen to be at a very different kind of school from Matt. I'm at a smaller college, which has a bigger teaching responsibility, and so his 60% in research comes down to about 10% for me, because most of my load is actually teaching undergraduates. And I teach one graduate class, but that's they're more independent. But this teaching undergraduates and dealing more with their psychological state of mind and their wanting to figure out where to go next in their lives and their career options. They're very chatty. They come by office hours, and that just blows more than an afternoon. It blows weeks at a time, and then you look around and a grant is due and you think, oh no, where was the past month? I have no idea where it went. And the other thing that happens at a smaller school, I have a lot of committee responsibilities, and so I sit on numerous panels, and being in science, I happen to fill the hat of a minority person that needs to be on the committee, a woman that needs to be on the committee, so I get pulled onto committees beyond belief, and I have to kind of back off and say, listen guys, there's still grants to be written and research to be done, otherwise I don't get tenure. So this time management thing has been basically the biggest surprise, because as a postdoc, you're just happily doing your research, and then you spend time writing a few fellowships, and so that's kind of like grant writing, and so all your time goes into that stuff, and it's a very cozy world, and then it just gets blown to bits when you have many other things on the table that everyone expects you to do. So your teaching, research, and service components come up on your annual evaluations, and you have to kind of meet all of those needs, and there really never is enough time for everything.
Thanks for coming to this committee, by the way.
Yolanda, you just mentioned tenure, and our next question is actually about this. This comes from the audience. The Chronicle of Higher Education reported that about 70% of the instructional faculty at all colleges is off the tenure track, whether as part-timers or full-timers, a proportion that has crept higher over the past decade. This person that asked the question was just wondering if you could comment on the tenure track and any sort of information that you have about that for us.
Well, in our department, it's still relatively traditional, but it's definitely true that we're trying to move into non-tenure track teaching positions, and actually those positions are quite serious and quite long-term at our university. But I think that there's definitely a trend towards non-tenure track positions. But I think those are really where a lot of the hard work is done. In our university in particular, and just in chemistry department, we have about 1,200 students taking general chemistry. So it's actually broken into 4 sessions, and 2 of those sessions are by tenure-track faculty, and 2 of them are, right now, they're adjunct positions, but really it would be ideal if they were at least the non-tenure track full-time positions.
So at our college, the tenure process, no one really explains or writes down exactly what's needed, but it's understood through, the gossip loop that if you teach 3 or more classes every year and you get good student evaluations have a high weighting when you go up for tenure. And if you're too hard on them or they're failing too much, then you may get very difficult student evaluations, which could affect your tenure process. The second component is being on many committees. If you sit on many departmental committees with administrators, the president, the provost, the dean, and so on, and you get to know those people, then your tenure process, you're basically fulfilling that committee arm. And of course, your research. You must have publications, many per year, which hopefully you have enough students that can help you through that. And you must bring in grant money, and so that's also very difficult. If you have those met, then it's pretty assured that you're a good candidate for tenure. If you don't have those met, then after about 7 years, which our tenure clock at your college happens to be 7 years. It used to be a 5-year clock and recently got to 7 years when I joined. And so you have 7 years to basically produce all of those items under the 3 arms. The difficulties are, so for tenure track faculty, you know exactly somewhat what your requirements are, but then most of the students are taught by adjunct faculty. And it's cheaper for the university to have adjunct faculty because they don't have to pay for health insurance benefits, and they don't really have to renew appointments when teaching load or teaching schedules become thinner. Then they can just not have as many adjuncts and so on. And so most universities have a huge amount of adjuncts, which actually changes the dynamics of how your students are taught. They may not get as good, you have very good adjuncts, but they don't get very streamlined and focused and evaluated teaching, because the adjuncts can go to different schools. They just change schools from semester to semester, and so it's not continuous and not homogeneous in the way they're taught, and so you get different levels based on who the adjuncts are. So you have students taught by adjuncts, and then they end up in your class, and then you think they should have a lot of prerequisite knowledge, and they actually don't because the adjunct skipped a few things and no one really looked over that. So this difference between being tenure track and non-tenure track, there's less of a responsibility to the university if you're non-tenure track, and this high responsibility to the university as a tenure track faculty. So the burden is on your shoulders to basically maintain a standard that your school, the reputation that your school will have outside of the college, because of the extra things that you have to do to basically make every student basically produce at a level that you're proud of as a tenure track faculty.
Yeah, I think if I want to comment about the absolute tenure track for faculty at Syracuse, for example, it's quite ambiguous as well. We have 1 review per year where you sit down with the chair and you go over your year's progress. And just as a counterpoint, the teaching evaluation is not really discussed so much at the end. It's how many publications, how many grants did you write this quarter or this year, how many students are you supervising in your lab, are there any problems between those students in your lab, and kind of the scholarly progress, I would say. So it's quite different in terms of the teaching. You have to have good evaluations. There's really no doubt about that. If you're a bad teacher, you're on your way out. But it's very low on the tenure track list, at least for me, luckily.
All right, thank you. So the next question is for Tianna. First, I was just interested how you managed to choose a career in publishing, and we were wondering if you could tell us about sort of your responsibilities in the everyday job, and maybe comment on how your PhD skills have helped you to make a transition into that sort of non-traditional career.
Those are a lot of questions at once, so I'll try and remember all of those. Let's see, how I chose to go into publishing. A couple of years into grad school, I realized I didn't want to stay at the bench, and so I had to do a lot of soul searching and career searching. And luckily, I had a very generous and kind mentor and advisor who was very supportive of me exploring what else I could be interested in using my degree in. And so he let me reach out to a number of different resources at the university to just do some career exploration. And I had just kind of started by looking at everything because there's so many options. And so I went through a process of looking at industry, which is where I think everybody starts, and thought about the bench work in industry and the management tracks in industry, which led me to looking at tech transfer offices to get some experience, kind of like in the entrepreneurial area. So I started kind of being involved with the tech transfer office, and getting an idea of what they did in the marketing and the patent law there, and I decided that wasn't quite a good fit for me. So I started thinking about, I just did a lot of reading, and then I kind of fell into science communication and writing and editing. And so I went to a writing workshop, and I started kind of looking into the resources for writing and editing, and I found that was a really good fit for me. Both my skill set and just kind of what I was interested in. So I was able to try it out at the communications office at the university and try my hand at writing there and just to see if I enjoyed it, working with scientists, interviewing scientists, working with the media. And I found it was just a really natural fit. And so I decided to kind of just pursue it from there. So let's see, my editorial roles. So basically what I'm responsible for is, if you've ever hopefully read a copy of Science Magazine, you know that it's divided into sections, the news section, commentary, perspective, and then it has your research articles. And then in the back of the magazine, before the advertising, we have life science technology articles, and also career features that happen a couple times a month, and a new products page. I'm basically responsible for putting together the content for the life science technology articles that talks about what kind of technologies are commercially available for you to use in the lab, and also what kind of technologies are being developed in academic spaces to potentially become commercialized, and how that's advancing a lot of different fields: genomics, proteomics, cancer, neuroscience research. We also cover just the other part of my job is the careers, and so what's happening with alternative careers. So we cover the biotech space, then pharma, we cover academia, industry. So basically, my experience in grad school doing all this personal career exploration, I'm trying to keep this all going since there's 3 questions here, had led me to starting a career club in grad school with 2 other students. So I kind of had folded all that experience into starting a career club, and then I had started a newsletter covering the biotech and academic space. So all that experience kind of naturally transitioned into my editorial roles now, where I cover the same kind of career space in biotech and pharma, just kind of instead of on a local level in Colorado, it's more in a international level now. But then I also put together the new products page. So I sort through and edit press releases that I receive from companies and choose who goes in the new products page every week. We also have, I'm part of the custom publishing office, so we also work on booklets and webinars that companies and universities can sponsor to showcase their research. And so when we have these special projects come in, I can also be working on those. Is there a third question?
Yes.
Was that it?
Yes,
Yeah.
yes, thank you. Now we'd like to open the discussion up to all 5 of you at once. What resources here at Brookhaven or elsewhere did you use while searching for your job?
Feel free to jump in, anybody.
I'll go and say that your mentor is a very important resource, and who they know, and if they have high esteem for you and can write nice letters, and this is all very helpful. And other resources are people that you've met in places outside of Brookhaven. So I find that getting a job, it's very, very useful to know people inside where you're trying. And it's not that people are going to give you a job, but you can, if you have a friend that works for a company you're applying for, they can tell you what this job might be about, and you can learn about the job from them and be better prepared for an interview. So people are a really important resource.
I would agree with that because I was transitioning my career and I didn't have any formal education. Some people transition into journalism and communication by going and getting another degree, and I chose not to do that. And so it was really important to me to have the professional relationships that I built here at BNL, to have the references, and also to fill in the gaps in my experience in journalism and communications, to learn from people that are experts in the field here. And also, a huge resource for me was the science here. It really widened my exposure to other fields of science, and since what I cover is so broad and wide-ranging with our life science features and our careers, I was able to learn all about nanomaterials and engineering and particle physics here, and ecology, and more about neuroscience. And so just the science that was going on gave me more exposure here at BNL.
I found mine just through kind of applying to, a few dozen faculty calls. But at the end of the day, the reputation of the lab, kind of the high-tech exposure that you have while here helps tremendously in the application. But I would say the most important thing coming from BNL was the recommendation letter from your supervisor or a co-supervisor. So in terms of BNL helping, it was really the exposure of the lab to the science here, and having a very strong mentor who you worked very closely with be able to write a very strong recommendation letter. Or in terms of pointing you towards a specific university, I didn't really have that approach. It was more applying to many places and see what sticks.
Yeah, I'll add the professional societies, say like the ACS. I know I went to a couple national meetings, and they have, in addition to just really a lot of interviews, a lot of job postings, they have workshops for resume writing, for how to prepare for an interview. Those helped a lot, as well as, in addition to the advisors here, I also reached out to my PhD advisor. Same thing with the recommendation letters, and similar to Matt, it was really just anything I saw that I thought was either interesting or a really good fit based on skills. And here and graduate school, I was applying to anything I saw.
I'd also add that I see a lot of the same resources at BNL that I had at my university for when I was just going through a career exploration stage. You have a K through 12 education office, a communications office, a technology transfer office. These are filled with people who are great resources on and experts in the alternative kind of fields you can go into.
So I agree. Everyone has said that BNL is a really good place to come from because it's well recognized when you're going somewhere. I found that when I was applying for jobs, you have to keep an open mind in location. I happen to be a theoretical computational chemist by training, and so the year that I applied for a job, there were listings in North Dakota and Montana, in places that I wouldn't have normally thought that I would go, but I applied anyway because that just happens to be when a department, if you're choosing an academic route, for example, when a department has an opening, usually it's very specific. Not every year will you find an opening for an organic chemist at that department or for a theoretical chemist, and so you're kind of basically targeting your field, but it's not usually your ideal location. And so I just want to make the point that don't rule out Montana or South Dakota, because that might be where there's an opening that year, and then the next year there's no opening there at all. And so, or if there's an opening there, you already have a position that you won't be considered for in a new place. So you just have to be open-minded about where you want to be and what openings there are that year.
And I would also add to that, sometimes you don't want to be so specific about, for example, if there was a faculty position for inorganic biomaterials, but you're a hardcore only inorganic chemist. Maybe there's a possibility that if you got your foot in the door, you'd be able to expand, a little bit into biomaterials. So you can be a little bit brave to apply to positions that aren't necessarily, 100% your expertise, because at the end of the day, they're going to select research topics that they like, and these research topics are usually quite broad. Even though the call is very specific, the candidates that come in, usually they're, slightly maybe outside that field a little bit. So you can extend the search a little bit broader in those terms as well. You don't have to be so specific, and that helps out quite a bit.
Sorry. One other advantage I thought that was helpful coming from Brookhaven is the cross-disciplinary nature of my research. I was at the Center for Functional Nanomaterials, where basically I interfaced with physicists, engineers, and chemists. And so I find that the field is going more towards that cross-disciplinary array. And so the more basically names you can throw at your expertise, the better chance you have of finding a faculty position somewhere, because your research can fit under many umbrellas that they're looking for, or cross, have room for collaboration with some of your colleagues in the department. So that helps to come from Brookhaven, having this cross-disciplinary background.
Yeah, actually, if I could just step in one last time, collaboration is actually key some places. So a lot of, faculty, especially, older faculty that they don't, maybe they're winding down their research, they want to find maybe a new protege or a new early faculty to kind of collaborate with a little bit. So actually, when people come into the department for not review but interview, looking at potential collaborators, can I work with that person? It's actually kind of a big deal. So when you craft your cover letter or something like that, you want to maybe point out a few faculty who you might be able to collaborate with, if you were there. Because a lot of faculty, they really look for that collaboration possibility.
All right, thank you. At this point, if anyone in the audience has a question, I think there's some mics in the middle, or you can just speak very loudly, whatever you prefer. But go ahead.
So I'm actually a PhD student now, and I'm a user at BNL. So if I were looking to apply for a postdoc position at BNL, or even something, I don't know if there's like summer opportunities for a PhD student, what suggestions would you have to put myself in a good position for that?
I guess I can answer first. I think when I applied to BNL, there wasn't necessarily an opening, in the jobs section. I emailed, a few researchers who were in either catalysis or nanomaterials, really to kind of probe their interest. And once we had a little bit of maybe an email back or forth or so, then we kind of maybe waited until a position opened or something like that. So I would say you really want to not send 30 emails, but 2 or 3 very specific emails to see, in the future, are there any openings. But I also was a user as a graduate student, so that helps a lot. You kind of know the environment. Maybe you've met a few people.
I'd say you have a very big advantage because you're here already, and you can go knock on someone's door, and I think advisors are probably looking for enthusiastic people, and you approaching them is a good sign. I mean, it shows that you have interest, and so that's a big advantage, and it may or may not amount to anything, but that's where I would start.
Any other questions from the audience? I'm sorry, Ovi, would you go to the microphone? Yeah, thank you.
Okay, my question is geared to the academic panel. If you're applying for an assistant professor position, which of the components of the application do you see as the most important? For instance, is it the cover letter or the research statement or the teaching philosophy? Could you just comment on those, if you haven't.
Well, sort of, you have to figure out what kind of school you want to apply to. If you want a more research-based school like Math's or a more teaching-centered school like mine, that will carry the weight of the application. So for a very teaching-centered school, the research component is actually just as heavily weighted as the teaching statement, because even at a teaching school, they want you to be engaged in undergraduate research quite a bit. And so your research direction. What was helpful for my application is having this connection to Brookhaven, where I talked up a lot about how I can bring my students back to Brookhaven and expose them to the grandeur of Brookhaven and give them things that, even though they're in Queens, and it seems very close to Brookhaven, this is a very foreign world to be 60 miles away, and all the things that are going on here, it was very interesting to them to come out here. So having this link to Brookhaven and still being in New York was a very advantageous part of my application, and that was just kind of the luck of the year, I suppose. And so your research component is actually the #1 feature that they look for no matter what school you're going to. They want to know that you can bring in funds because it helps them in their budgets, and there's overhead that comes off of your grants that goes to the college to support their other initiatives. So they want to have people who can bring in as many funds as possible. So the dynamic nature of your research and the more eye-catching it is to bring in funds is what they'll look for most.
I agree with Yolanda that the research component is really the key. You want to make sure that your application isn't really duplicating anyone in their department necessarily, so you're kind of bringing a new research area, and also the potential funding routes for the fundamental science that you're proposing. So we see a lot of applications talking about the grand applications that can come from a particular material. So, but really, when you're in the lab, it's focusing on fundamentals, especially in chemistry department. But I personally think that a well-crafted cover letter is extremely important. So if you can break down your whole application, your background into a good cover letter, I think that's particularly important. Especially if you can judge from the cover letter kind of the how likely is this person going to be to accept the position if we offer it to them. So for example, if you just have a very generic cover letter that you send to everywhere, there's really no personal information kind of in it. So it's hard to judge, because at Syracuse, we have new faculty, maybe 4 people are coming in out of 100 applications. And if I can judge in this cover letter that obviously your research is good, but you're also interested in, maybe the surrounding area, or you have some other kind of personal effects that kind of tell me that this is a really good candidate, and if we offered him the job, he would kind of accept it. I know it's kind of very vague, but I think a good cover letter helps out a lot, because there's 4 people on the committee, or 5 people on the committee who are reading these 100 applications. This cover letter has to be kind of perfect and jumping off the page for them to flip through the rest of the application.
One more thing I would say, as far as your research proposal, now that I'm on search committees and I can see from the other end, what people like to see on the committee is basically the longevity of your research and the cross-discipline nature of your research. So make sure that your research proposal can carry you through for a good 7 to 10 years and that continues to be vibrant. The fear at my college, for example, is that I am replacing a lot of retirees, and so they want to be able to keep a good, strong, undergraduate research component going for the next few years. And so make sure your research isn't too narrow or isn't too short-lived, because that could quickly eliminate your application.
And in the research, try to personalize it for that university. So, for example, if you're cross-disciplinary, you can use the computing center in Department X, or the electron microscope in the engineering department. So if you kind of already have a little bit of these ties where you can use many parts of the university, that also helps. It takes a lot of work to personalize each one, but it helps the application stand out quite a bit.
Anybody else? I think we have time for one more, maybe. Yeah.
So let me just repeat that question for everyone. The question was, for industrial jobs, how do you market yourself after doing fundamental research in order to get those jobs?
So I'll start. I think, so there was a seminar at Stony Brook by a couple of guys that I now work with on their battery program. And I went to that seminar, and it turns out the job that I had applied for was actually one of the guys that came down was one of the people on that committee. So I talked to him about it there, and that was sort of, I guess, a little bit of luck. But in general, like Carl said, as long as you can use your technical background to solve problems and put that forth in whatever interview, talk, or face-to-face interviews you have, I think that's the best thing you could do, is show that whatever the problem is, it doesn't necessarily matter. It doesn't have to. If it's close to what the job is looking for, that's great. If it's similar, that's fine. As long as you can say there was this problem, I used these skills and these experiments to solve that problem, I think that's exactly what they're looking for.
Yeah, because when you apply for an industrial job, you're not going to be writing a research proposal in most cases in your application. So you don't really have to base it on a narrow area of your expertise. What's more important is your skill set, and it's much beyond research. I mean, it's being able to interact with people. So there's elements outside of your fundamental, topic that you're studying that are also important for an industrial job. And meeting people. You met someone at a conference. If you meet people that are in the industry that you're interested in applying to, that's very, very useful. And the personal, getting to know someone on a personal level and not just in the research area is important, just because you're going to be interacting with a lot more people, and that's something that you would be evaluated on in addition to your research. I mean, it is almost equally as important. So it doesn't have to be all about your research, but if you can find something that you do that your research may not apply to a product, but the skills you've developed will. That's my advice.
I'll add to that and say that I'm a chemist, and when graduate school was, the only people I talked to were, for the most part, were chemists, organic chemists, inorganic chemists. It doesn't really matter which subdiscipline, chemistry. Came here, there's a lot of people that are not chemists. There's physicists, biologists. I didn't necessarily work with them all the time, but I interacted with them on a daily basis. And I would say now that's gotten even broader. There's half of my lab is engineers, chemical engineers, environmental engineers, and you have to be able to interact with them on a daily basis. There's people in the business programs that are not necessarily even scientists that you have to be able to communicate with and interact with. And I think Brookhaven helped in terms of preparing you for that. So that's another thing I would highlight, because that's very important.
Oh, do we have another question?
We have a question. Hi. I wanted to follow up on the comments that were made about your experiences at Brookhaven. From what I've heard so far, it sounds like coming from Brookhaven was largely constructive and helpful. You said lots of good things along those lines. So the question is, well, what didn't we do that might have been helpful? Or where were some of the lessons learned? And the one area that did get touched on a little by Matt and I think Yolanda was concerning the other responsibilities that, say, a professor encounters, like HR-type responsibilities or going to meetings. When we've been thinking about our mentoring program here and the way we're going to broaden it, we've been thinking about coupling into Stony Brook, that is sort of doing it together. Maybe that would help with some of those issues, for example, the HR-type issues or the committee meeting issues, maybe. So it's really a two-part question. One is, what didn't we do? And then, what do you think about hooking up with Stony Brook in that regard?
I'll go and say that as a postdoc, you're really focused on research, and your mentor I feel like I learned afterwards, protects you from a lot of things that would distract you from research. But at the same time, you kind of miss out on learning about the administration of research, because I think no matter what job you move to after a postdoc, you're going to have to learn to manage more than just a research project. It might involve managing people or budgets and those kind of things. As a postdoc, we were rarely exposed to unless you put yourself into that situation. And if mentors were more inviting, even though it might take more time for them to incorporate, teaching you about those things, it would be a big asset.
I definitely agree with Carl that kind of the supervisor here kind of shields you a bit from those, maybe those nitty-gritty things that would distract you from research. But I think that, a little bit of interaction with Stony Brook would definitely improve or help, especially the academic transition, because when you're a PhD student, you're also very focused, so you really maybe don't see all the details that the postdoc in your lab is doing. But when you're here, you're so focused only on research, so a little bit of outside research interaction might be a little bit beneficial. But that being said, for me, I was only interested in the research. I really wasn't so interested in necessarily supervising, students or committee work. So I was quite happy with my work. But it's true that some interaction with a committee, sitting on a committee of scientists might broaden things very well, or helping to supervise a graduate student or working with a graduate student from Stony Brook might help also quite a bit.
I think being a postdoc here and doing only research is actually the thing that gets the job done, because when you go out for the interview, they're only looking at your research. So spending a lot of focus, as I did here, on the research only, that's 100% of what you need to get the job. The other things that come in, like committees and so on, when you're an academic, it's just a phase of life transition, like going from being, a high schooler to a college person. You just figure that out on its own. The one thing that could be incorporated into being a postdoc here is a little more grant writing, because you really have to be efficient about grant writing once you're at the next phase. But between research and just a touch of grant writing, don't change anything else. You don't have to throw your postdocs on more meetings. No, I'm already a disadvocate of meetings, if that's a word. And so more meetings doesn't really give you any advantage at all, but more research and a little bit of grant writing expertise is what you would need, I think, here at Brookhaven. And I didn't get a lot of grant writing exposure when I was here at Brookhaven, so I kind of dove into it quite a bit when I started my academic career, but getting a little exposure. And actually, the grant writing here at Brookhaven would be very different from the grant writing at my university, because for example, at the CFN, there's kind of a group grant. There isn't a grant specific to any small, so I was in the theory and computation subgroup. There isn't a grant for that subgroup. There's a grant for the CFN. And so I would never have been exposed to a grant for the CFN, whereas now I'm at a university, I have a group grant just for myself and my students, which is local to my research. And so I don't know if being exposed to CFN grants would have helped me at all. It would have just distracted me from research. And at the end of the day, they wanted to see publications and research when I went for that interview, and so that's what I got by being at the CFN.
Yeah, I would say there's really maybe not a big rush to get into some of these other things until you have this change of life, like Yolanda said. But maybe a committee with your department, some little subcommittee being part of that, might be quite worthwhile.
I would just say that committee work was actually really important for me to secure my position, because I would in grad school, I sat on the local chapter for the Society for Neuroscience and helped organize the local chapter meetings. And working these sorts of teams really helped prove that I could work in teams and these sorts of skills that were really necessary to transition into something besides research. So I thought that was really helpful.
I would just also like to suggest that if you're looking to add some things to your resume, take part in next year's YRS organizing committee, and hopefully that will help.
Okay, well, at this point, just in order to maintain our schedule, we're going to have to wrap up, but we're very happy that all of our career panelists will be around and milling about for the rest of the day. So please take advantage of their presence and ask them any further questions that you may have. And in addition, Tianna has brought with her a few documents which are on the front of the stage, which will really help to kickstart your job search. And after the career, they'll be moved to the front desk. So make sure you grab some of those. And I think if you'll just join with us, we'd like to thank our career panelists for their insight today.